what is the net result of this?
0.
Equals 0. And is this true? Like, does zero equal 0?
Oh, yeah.
Yes. Okay. So this has a meaning. This is a meaning in your math class here. We'll get to that in a moment. Let's say it's something else. Let's say it's 3x. Let's go minus 3x plus 4 equals minus 3x plus 5. And we'll do the same thing. So we'll add 3x to both sides. And then we get 4 equals 5. Is this true?
No.
No, this is not. This is bad. The previous one's weird. It's like, okay, yeah, that's true. But this one is definitely not true. So what this leads to is the idea that all equations have the following possibilities. Okay, the first one is the ones we like, where x equals a number. These are the ones we've been doing all along. Like, x equals 1, x equals 10, 1/2, whatever. Okay, but it could be 0. It could be x equals 0, believe it or not. The second possibility is that there is no solution. You might be like thinking, well, how does that? Well, that is a possibility. That is when you get number equals number, but they're not the same. So the example of that would be like 4 equals 5.
Mm-hmm.
The third possibility, and there's only 3, is what's called infinite solutions. Okay. And sometimes it's written this way, infinite, the infinity symbol solutions. And this is 0 equals 0. It could be number equals number, but they have to be the same. An example would be like 3 equals 3. Okay, or 4 equals 4, whatever. But it's the same number. Okay. But these are the 4 possibilities. The second 2 are what I call the exceptions. They don't happen that often, but they do happen.
Okay.
So let's look at a few more of these. And if you recall, there was a bunch of other things that we could do to solve these. Like you might be asked to do to distribute. You might be asked to combine like terms. You might be asked to move to one side. And generally it's the smaller to the larger. Now we did these a couple weeks ago, but I'd like to try a couple of these problems with you. And see what you think here. So let's do one together. One or more. We may do a couple. All right. So here's an equation to solve. What is the first thing to do here on either side of the equation?
Distribute the 12.
Yeah. So 24k plus 132 equals 24k plus 144. And what you start noticing when you do these is that if the variable is the same, the same number in front of the variable, you're going to get one of these exceptions. Okay. So this time when you subtract 24k from both sides, you end up getting 132 equals 144. And the reason I ask if this is a true statement is because I think this is the most reasonable way to sort of think through these is like, well, is it true or not? Like, are these numbers the same? No, they're not the same. And since they're not the same, there is no solution.
Okay.
Okay. But this is not to be confused with the following. If I could find it here. So let's look at, and this is not an exception. This is not an exception, but for some reason it gets perceived as one. So this time we're going to distribute the -8 to both terms here. this becomes -8 minus 56n minus 5n like that. All right, and then you can combine like terms. You can combine the minus 5n, the minus 56n, minus 61n, minus 8 equals -8. Add 8 to both sides. Minus 61n equals 0, divide by -61, and n equals 0. And this is okay. This is okay. This is not the same. If the variable is left over, that's okay. The issue is when the variable goes away, that's when you have a problem. So if you're taking notes, the exceptions are when the variable goes away. That's what you're looking for.
Okay.
All right, so let me see if I can find a few. I have to go to another student's notes. Yeah, give me just a moment to find some props. Any questions so far on what we've been working on?
Mm-mm.
So here is a first problem for you to try. Excuse me. All right, so go ahead and work this out and let me know what you come up with, please.
I got 36 equals 35.
Good. Now, what we're looking for after this is which of the possibilities is it solution, meaning x equals a number? Is it no solution, or is it infinite solutions?
No solution.
That's correct. So your instructor wants to see these words plus the work, like, you know, um, you have to be able to work through that. And you did great there. Um, ready for another?
Sure.
Okay. All right. Go ahead and give that a try, please.
I think I'm having a little trouble on this one.
Okay. When you distribute the -5, do you have 10 plus 40M?
Yeah,
All right. Now you move the smaller to the larger. So which is smaller, the 5M or the 40M?
5.
So you subtract 5M from both sides. And what you should notice that's really important is that the variable remains, which is good. Okay. Now you just solve the equation. Now when you subtract 10, 35M equals 0. This is maybe where you're like, huh, I don't know what to do here, but you still just keep going. You divide both sides by 35. So M equals 0.
Okay.
So this is not an exception. This is okay. It's often it's often put in with the exceptions because it looks like it doesn't work out, but it really does. Okay, let me give you one more to try here. I'm gonna step away for a minute while you're working on it. I have an angry cat that bites if she doesn't get fed, so I'll be right back. And we'll look at, you can try this or we can look at it together, but give me about a minute, please. Right. Let me know if you have any questions, if you want us.
I got 3 equals 3.
Okay. What does that in terms of
Uh,
what would that mean in terms of the solution? Let me go back up here in case you need to look at these. These are the three possibilities. Snip those in here.
would would that be uh
Sometimes you use process elimination. Is there a variable in your answer? Do you see any variables?
no?
Letters. So that one's out. Nope. Okay. Why was the last one? Why was this one up here no solution? What made it no solution?
Because it wasn't equal to the other.
That's right. So that one's out. So what must it be?
Infinity.
And infinite solutions. This one is sometimes also referred to as all real numbers. All right. So I actually did this in the wrong order. We should have done parallel and perpendicular lines first, but oh well. We'll do that next. So any questions on this before we move away from it, or any thoughts?
Mm-mm.
Okay. So let's So we kind of addressed, well, this is kind of related to the following. So these two lines are considered parallel. Have you heard that word before?
Mhm.
Okay, so in math, we say that they never intersect. And you'll see these in your geometry class as well. They never intersect. Okay. What makes them never intersect is that they have the same slope. Same slope. Okay. So let's look at that in a little more detail. Let's say I write the equation y equals 2x minus 1. Can you tell me the slope from this equation? Do you remember that this is an mx plus b form?
Mhm.
What would the slope be? Any idea or not? It's okay if you have no idea.
Um, I kind of forget how to.
Okay, so the
Yeah,
slope is the number in front of x. What number is in front of x or to the left
two.
of x? 2. So the slope is 2. Okay, and the b value is the other number.
-1.
-1. Good. Okay. Now let's give you a second equation. Let's say it's y equals 2x plus 1. What is the slope? What is the b value?
2 and 1.
2 and 1. Okay. I'm going to graph these for you. I'm going to put the graph in. Have you used Desmos scientific graphing calculator before?
Mhm.
Okay. I really think it's a great tool to use. I'm not opposed to technology. I embrace it. Uh, Although AI is kind of worrisome in some things. But these lines here, they have the same slope. And do they appear to be parallel?
Mhm.
Yes, they never intersect. The only thing different about them is the b value. Okay, so the main takeaway from like this part of the lesson for like the second half is that parallel lines have the same slope.
Okay.
Okay. And we're gonna write some equations, we're gonna solve some equations, and so on. All right, so I'm looking for some questions here for us to do, talk about. Um, all right, let's look at. So we're looking at a new problem here. This is the typical problem you'll see. They'll give you two equations like this. Let me get rid of this 10. And they'll ask, are these lines parallel? Okay. And to answer that question, you have to your answer is, well, they're parallel if they have the same slope. Like you know that now. You're like, all right, same slope. But maybe you know the slope for the second equation. What is the slope of the second equation, if you know?
-2/3.
You're 2/3. But if I ask you the slope for the first equation, you're like, I don't know. Actually, this one's got an error. It should be 2x plus 3y minus 6 equals 0. Okay. So this is in standard form, kind of. And I don't remember if we did much of this yesterday, last time, but you can actually put this into slope-intercept form. by solving for y. And the reason you would do that is to get the slope, subtract the slope. Right. So let's do that here. Let's add 6 to both sides. Let's subtract 2x from both sides. So we have 3y on the left equals minus 2x plus 6. Okay. Is this solved for y as is?
Mm,
Is y by itself?
no.
No, it is not. So to get y by itself, you divide by 3. Now you divide everything by 3. So y equals minus 2/3 x plus 2. What is the slope of the second equation?
Negative 2/3.
Negative 2/3. Is that the same as the slope of the other equation?
Yeah.
So are they parallel?
Mhm.
Yes. Okay. All right. So let's look at another problem here. Let's say I write y minus 1 equals negative 2x plus 1. What is the slope of this line?
Would that just be -2?
It is, and it's because it's in that point slope form. And the slope would be -2. Okay. Now let me give you another one. Let's say it's minus 2x, okay, minus plus y, sorry, minus y equals 3. Okay. So this one we don't know the slope of because it's not in a form, it's in standard form kind of ish, slightly. We really should solve this for y. Okay. So if you can't tell, there's a skill here where we have to take these standard form equations and solve them for y. So you would do this by adding 2x to both sides, and you generally put that in front of the number. Okay, so it's minus y, that minus goes with the y, 2x plus 3. It's really a -1 in front of the y. So you undo -1 by dividing everything by -1. This becomes y equals minus 2x minus 3. What is the slope of this one?
-2?
-2. So are the lines parallel?
Yes.
Yes, they are. So there's a skill here, and we kind of talked about last time. It's to be able to take a line, something from standard form, and be able to put it into, this is the ax plus by equals c form, and put it into y equals mx plus b form. And the reason is actually, let's put the equation here, slope-intercept form, is because we want to be able to extract the slope. Is that okay?
Mhm.
All right, so I'd like you to try the following. 5, let's not do that. Let's go 2x, sorry, bad choices here. 8x minus 4y equals 16. Okay. And I want you, just like we're doing here, I want you to put this into slope-intercept form.
Okay. Oh, that'd just be like -4y equals 8x plus 16.
No, it has to be completely solved for y. So again, you move this first thing over, put it in front of the number, and then if you need to, you undo, like if there's a number in front, or you have to divide it out. It's
Okay.
like you're like, this 8x is positive, so you want to subtract it.
Oh, would that be like y equals 8?
Okay, let's try this again. So you're subtracting 8x from both sides. All right. That goes in front of the number because it doesn't combine with the 16. 16 is like apples and minus 8x is I don't know, oranges, whatever. So you have minus 4y equals minus 8x plus 16. So I think that's what you've been missing here when you see this. Now, you divide everything by whatever's in front of y. And I'm choosing things that work out nicely for now. We'll get to some that do not. So this is 2x minus 4. This is your final answer.
Okay.
So maybe get this down in your notes. That way you've got a reference problem.
Okay.
And let me know when you're ready. We'll do another problem here.
All right.
So here's a problem for you to try. 3x minus y equal, whoa, that does not look like a y. 3x minus y equals -4. So again, solve for y.
Y equals 3x plus 4.
Like this.
Yeah.
You got it. Very good. Okay. Now it is not the case that things always work out nicely. Like you might get a problem like this, like 2x minus 3y equals 9. Okay. And it's still the same recipe. You still move whatever is there. And again, I always recommend putting it in front. Minus 3y equals minus 2x plus 9. But this time when you divide by -3, you get y equals 2/3 x minus 3. So sometimes the number divides into one or the other or both, but that shouldn't bother you. You shouldn't, you should just be able to go along with it, whatever that is. Sometimes you get a fraction that reduces. Sometimes you don't. And these are all things that can happen in this part of the course. So look for another example or two, and then we'll go back to some of your problems. The yeah, like here's one for you to try. Go ahead and solve this for y, please.
I got y equals 3/4 x minus 2.
Like that?
Mhm.
All right, good. Very good. Okay. So we do all this in an effort to figure out if lines are parallel or not. And then we'll get into more. This is actually kind of a geometry thing that you'll do later on, but the not much. Um, um, so what I want to do is give you a couple of equations here. Like let's say it's y minus 3 equals 4 x minus 1. And that's equation 1. And then equation 2 is 4x minus y equals 2. And you have to decide if these are parallel or not. And so the only way to do that is to um, is to figure out the slope of the second line. Okay. So the slope of the first line is 4, and the slope of the second line is, well, you have to figure that out. So if you want to do that for us, and then we'll talk about some perpendicular lines.
Alright, I got y equals 4x minus 2.
Okay, I agree. And what is the slope of this one?
4.
Good. These are parallel.
Mhm.
All right. Now, there's another thing that they could be. That's not, could actually be a lot of things. So the next type of thing you'll see in this is perpendicular. And you'll see that a lot in geometry. Perpendicular means that they meet at 90-degree angle. You'll see that in geometry. So the first thing is that I'm going to give you a slope, and then I'm going to
Okay.
give you the perpendicular slope. The perpendicular slope to this is -4/3. I'll give you another slope here, 5/2. The perpendicular slope, that little line means perpendicular, is -2/5. Give you another one here. Let's say the slope is -2/3. The slope perpendicular is 3/2. I'd like you to, and we only got like 2 minutes, so I'll ask you just, or I've got 4 minutes, sorry. I'll ask you just to briefly look at this and see if you can determine the rule for the perpendicular. There's a rule.
Are you just like flipping it
Like how,
over and making it negative?
yes, yes.
Or
So
if
there are
it's
two ways
negative?
that, there's two ways that people say it. Opposite reciprocal, which is what I like. That's not the only way. The other one I've heard is flip, negate. In either case, you are flipping and then negating. So if one's negative, the other's positive, one's positive, the other's negative. And that's all well and good until you get to, what do you do with a whole number? Like, let's say the slope is 3. Well, you have to write 3 as a fraction, which is 3/1. So the perpendicular would be 1/3 negated. And what if the slope is -4? Well, again, you have to write it as fraction. So the perpendicular is 1/-4 negated, which makes it +1/4. Is that clear?
Yeah.
Okay. Now, one more little thing here. I'd like you to multiply 3/4 and -4/3.
Okay.
And tell me what you come up with.
Got -1.
Okay. Let's try it for the next one. What is 5/2 times -2/5?
-1.
What is -2/3 times 3/2?
-1.
Yes. I'll spare you the suspense. 3/1 times -1/3 is -1. And the last one here is also -1. So the slope times the slope perpendicular is always -1. And that's an important thing that you'll see in other courses down the road. But for now, that's just kind of maybe a check if you're unsure on that. All right, good job today. We're gonna go ahead and stop right here.